After spending some time working with position and distance and displacement as we talked about in class, and using those on a coordinate plane, it's important that we jump back a little bit and discuss something known as graphing. So we're going to move back into the book, into chapter 2.3, graphing. Now, for this video, we're going to have all three learning goals as part of what you need to be able to understand by the end of the video and then eventually for class. These learning goals are: use graphs to create a visual representation of data, analyze trends on a graph, explain the difference between a direct relationship and an inverse relationship. So graphing is extremely important in science. We use it all of the time, nonstop, to help us explain data. And what a graph is a visual way to organize data. It puts it into a picture. It takes a table of raw data where it's just a bunch of numbers and columns and puts it into an image that makes it easier to understand. The type of graph that we are going to work with for the majority of this year is what's known as a scatter plot or an XY graph. And we use this to see how two variables are related. Remember, we discussed, or we have talked about, what a variable is. It's something in an experiment that you're going to physically measure. And we're going to have some different definitions for what exactly those are. But that image you see on the right, that is an example of a scatter plot. You've got two different variables in that example, mass and volume. And we're seeing how one thing is affected by the other. Now, there are a few other different types of graphs, such as a bar graph, pie graph, and line graph. And I'm going to give you this handout in class, but like I said, we're going to spend almost, or what we're going to use for the majority of the year is going to be the scatter plot. So on a scatter plot, as we said, there's going to be two variables. And we want to see how each of these variables are affecting one another. We've given them a name: independent and dependent variables. So again, scatter plots are going to show how a change with one of these is going to influence the other. How does one thing affect the next? The independent variable, this is something that you as a scientist believe might influence something else. So you're changing. That's going to be something, if you're doing an experiment, that's going to be what you're physically changing to see if something happens. Maybe you want to see how some type of metal changes its appearance as its temperature changes. Well, you would change the temperature slowly, 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 and that's your independent variable. You're physically changing it to see how something else is affected. The dependent variable, that's the thing that's a variable that you hope will change as a result of the experiment. That's what you want to see something change. And it's important to note that it's not always going to be changed. That's part of science. You're doing an experiment to try to find out what is going on with the world and how one thing may or may not affect the other. So here's an example. I love to go diving, scuba diving, and oh, look at me. I look goofy. Yep, there's a fish. Anyway, diving is a really, really fun activity, but it can be very, very dangerous. In fact, when you go down deeper and deeper and deeper into the ocean, because you have so much water around your body, it starts increasing the pressure. And pressure is really, really critical to safe diving. So a good question would be, how does an increase in depth affect the pressure? Because too much pressure could be bad for a diver. It can be bad for your body. So in that example, depth, increasing your depth, that is the independent variable. That's what you as a scientist or a person can physically alter. And the dependent variable, what you hope to see change or what you want to see is affected, is pressure. How does that increase in depth, your independent, affect the pressure surrounding a diver? All right. So, how we are physically going to make an X and Y graph or a scatter plot. They're one and the same. There are 4 things that you always need when making a scatter plot, and they're listed out for you now. The first thing that you have to do is choose an X and Y axis. So from our example, we have 2 variables, depth and pressure. Remember an X and Y axis, and I'll show you in just a moment this graph. I've graphed out for you depth and pressure. But you want to pick which variable goes on the X and which variable goes on the Y. In this instance, the independent variable, because that's depth, that's what you change, goes on the X. The independent variable is always placed on the X axis. The dependent variable is always placed on the Y axis. So you're going to put depth on the X, pressure on the Y. The next thing you have to do is make a scale. What does that mean? That means put numbers on those lines. So most graphs, a lot of the ones that we're going to use are going to do 1s, 2s, 5s, 10s. But there is another way that if you have maybe in the hundreds of numbers or thousands to figure out a good scale. And by scale I mean the line goes 1, 2, 3, 4, 5, 6, 7, 8, 9, or 2, 4, 6, 8, 10, or 5, 10, 15, 20, 20, 10, 20, 30, 40, 50. That's a scale. Increasing intervals. We'll work on this in class. The third thing you do is plot your data, which after working with a coordinate plane, you should feel a little more comfortable figuring out your way around the graph, figuring out how to read the X, how to read the Y, placing a point on that coordinate plane. And then the final thing you do is you add a title. Always title your graph. Now notice there's an exception when time is a variable. We'll talk about that in class. Just so you know now, time is always placed on the x-axis, but for now, don't worry about it. So this is an example of that scatter plot. First thing you do, choose an x and y axis. Notice that the x-axis has a label, depth, that's our independent variable, and our y-axis has a label, pressure. That's our dependent variable. Pressure is what we want to see change. Depth is what we are changing as a scientist. Notice that there are units in parentheses next to these values. Units. Extremely important. Oh, they're so important. Next thing, there's a y and an x value range. That is the scale that you place along. In this instance, if you look on the bottom for depth, that goes by 5s. Those are equal intervals for every line, 0, 5, 10, 15, 20, and so on. And the y-axis, you'll notice, don't go in those even numbers. But that's okay, and we'll show you how to figure out the scale to use. But they do go in an equally increasing scale. It doesn't go 1, 3, 2.5, 4.5. It doesn't do anything weird. It goes in an equally increasing scale. The data has been plotted, so you can see that there are points leading up, and then a title has been given. This title, it's not a very descriptive title, but it fits the purpose. Depth versus pressure. We'll work on in class giving graphs more meaningful titles that help you describe the data. But that right there, when you guys are working on graphs for the rest of the year, this is what your graph should look like. It should have all 4 parts. Your axis should be labeled with your independent and dependent, with units. You should have numbers on your scale, on your range. Your data should be plotted, and you should have a nice creative title. Now looking at that, what can that picture tell us? Well, I see it's a line and I see it's going up. So what does that mean? How does depth affect pressure? Think about it for a second. Well, as depth increases, so does pressure. So both values are increasing. An increase in one causes an increase in another. This is a certain type of graph relationship. This is what's known as a direct relationship. In a direct relationship, when one variable increases, so does the other. Take the example at the side. You've got speed and distance. As distance is increasing, speed is also increasing. Now, if you were to plot out all of your data and find out that you've got just a mess of dots all over the place, we say that there's no relationship. So this example here, number of musical groups versus last two digits of a phone number, there's no relationship here. So we just would say it's no relationship. One does not affect the other in any means whatsoever. The last type of relationship is what's known as an inverse relationship. In an inverse relationship, when one variable increases, the other decreases. So looking at the example on the right, how much money you have versus how much money you spend, as you physically spend money, the amount of money you have will decrease. So you keep spending, that's increasing, you're spending more and more and more, and the money you have is going down, 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 down. This is what's known as an inverse relationship. So that's the basics of graphing. I'm going to give you guys some handouts as well too, so you have them when you come into class next. But the important things are graphs, as you know, they're creating a visual representation of data that you take. Extremely important in science. Graphs give us a picture, and by looking at the picture and seeing the way that the line is forming, how the dots connect, we can know immediately how one affects the other, how an independent variable is going to affect a dependent variable. And we know now that it's going to be on either a direct, an indirect, or no relationship. And tomorrow when we come into class, or the next time I see you in class, we're going to work on our graphing skills. We're going to make sure that we have a handle on taking some data and being able to plot it. We're also going to work on identifying indirect and direct, independent and dependent variables, and how they're physically, when you give an example, which one's which, and just how to make a graph. And we're going to apply that to position, distance, and eventually speed and velocity back in Chapter 4 and 4.1. We just need to take an aside to make sure we've got this background and understanding. So I'll see you all next time in class.